Hi everyone, my name is Dalia Deeb. I'm from SDL Partners. Today I will be talking about the role of edge computing in driving enterprise digital transformation. So when we talk about edge computing, it's always important to do a quick definition on what we mean. I suppose one thing is to put into context, and from an enterprise perspective, it's really about changing the way IT infrastructure works and OT infrastructure works, and providing enterprises with more options. So before, as an enterprise or a developer, there were only, at the moment even, there are only a few options of where to run and compute and store data. And that's usually either on premises, in a data center, or it's in a remote data center or the cloud. Or sometimes, a lot of that data is also processed in the end device, which could be in a car, it could be in a machine in a factory, on a laptop, on a mobile device. And what edge computing is all about is moving that compute and processing in particular, and sometimes storage, closer to the end device or closer to the source of where the data is generated. So edge computing is partly a physical aspect. It's really about the compute being physically closer to that source of data, but it's also a software aspect in the sense that it's really about enabling enterprises to be able to move those workloads easily and to be able to access infrastructure in a very flexible and seamless way. So the question is always, then what are the benefits? And there's two ways to look at it. One thing is to say, okay, well, my status quo, my default option is to host the workloads in the cloud. And so, why should I move the cloud to the edge, or, why should I move those workloads to the edge? And the first reason is latency. It's always about latency. That's what tends to be brought up in these edge compute discussions. And low latency, is due to the fact that the data packet is having to travel across a sort of a shorter distance, if you will. That reduces the latency of the application, and so things can the round trip time and the overall application latency can be reduced dramatically by reducing the time between the data being sort of produced and then processed and sort of taken to the cloud. The second thing is the cost of bandwidth, and again, there is a cost associated with moving those data packets through a network or through multiple networks if we're going to the cloud, and bringing that compute resource closer avoids the need to have to traverse all over the full network. The last thing is data security, and this is becoming more and more prevalent and more of a sort of a key priority for enterprises, partly because of regulation, and you have increasing regulation that's being done at a sort of a national level, and also sometimes it's even at a sort of a state or municipal level, and that can make it very complicated for an enterprise to manage data and also to ensure that data is stored, especially in a sort of federated way, and the enterprise is aware of where the data is stored, because there are compliance issues related to data storage and security. The other thing is that enterprises themselves are conscious of their own privacy and security and cybersecurity issues, and we've heard a lot when we've done interviews, say from the manufacturing industry. The manufacturers themselves are very sensitive about their data, their sort of precious IP being in the hands of anyone else. So if they're running an IoT application in the cloud, for them that could be a sort of a security risk for them, because there is a cloud infrastructure company or even an IoT solution provider who has potentially access to all the IP related to how their manufacturing process works. Then the other way of looking at the benefits of edge is saying, okay, well, a lot of my compute actually happens on the device, or maybe in sort of more monolithic architectures on premises, or in sort of traditional, more dedicated appliances where the software is tightly integrated to the hardware and there isn't this sort of cloud-like remote management capability. And the reasons there for moving that to an edge, first of all, it's to reduce the cost of infrastructure, where you have where you have, a lot of the time an enterprise has to invest quite heavy amounts of capex to put an on-premise data center in place, or if each application, each software is on a separate piece of hardware, that adds up and that takes up space, and also it's costly. And you can see that in a certain environment, say in retail, that's particularly an issue where that real estate is expensive and they don't really want to be using that sort of precious space for putting in servers. They want to be able to consolidate that, and so taking that off the premises has huge benefits. The other thing is mobility. So the challenge of tying something to a device or tying something to a physical location on premises is that you then can't access that application if you move around, and you need that level of mobility. And enterprises, I guess, have been able to access IT infrastructure to enable branches to access applications, but it becomes more difficult when you have a very remote workforce where people are working from home, or people are there are workers sort of in the logistics field or field force workers. They always need to access the applications, but also need to access them in a way that's resilient and with low latency, and that's why you may want to run those applications at the edge. And then the last 2 points are about increasing flexibility and scalability. So again, bearing in mind that edge compute is also sort of about edge cloud, if you will, or it's a software element, and it's about bringing those capabilities that we have in the cloud around flexibility and scalability to compute resources which have traditionally been quite siloed in nature or monolithic or not as flexible. And by having sort of distributed cloud infrastructure almost on which could be on gateways, which could be in servers, which could be in mini data centers, being able to access all that compute resource in a cloud-like way is beneficial, because it again reduces that upfront capex. It makes things more agile for the enterprise, where they can scale up demand for their compute resources when they need to. And then the last thing is that by sort of disaggregating software and hardware and making edge compute accessing edge compute and using standardized flexible tools, that reduces vendor lock-in, where you don't have a single vendor to provide you the application, the software platforms and the hardware all integrated. You can go to different vendors for each part. And this sort of next slide just shows that in a different way, where you have I guess this framework that I've just described in a nutshell. So just to reiterate, low latency, reduced backhaul, data localization, those are key characteristics of computing applications locally historically. So an enterprise will always put their applications on premise if it's mission critical and low latency is critical, versus cloud-like capabilities are associated with the scalability, flexibility aspect, mobility, so being able to access the applications everywhere, having that level of resilience which the cloud brings, that sort of thing. And so the edge is really bringing those two sides together. And these benefits differ across each different industries, and this is quite a high level view of looking at it, but you as I mentioned, we've got industries like manufacturing, where much of the types of applications which are going to be running on edges are IT, but are also the OT applications, which are mission critical to running their factory. And so things around low latency, reliability, and keeping data local are paramount to them. But so is reducing backhaul, because with all that IoT data now being produced, with hundreds of sensors in a manufacturing plant, that is unfeasible to be to sort of go to the cloud, because of the amount of raw data that it will cost to try to go over the network. On the other hand, you have, I guess, industries like retail I mentioned, where there it's more around maybe taking applications or accessing applications which may have resided on a single device before. So, for example, we'll go through a few real life examples here, but in the retail store, you are trying to create immersive experiences, and a lot of the time that is tied to a physical device, which could be a big screen, a sort of digital screen, or it might be a augmented reality mirror. And historically, a lot of the compute has resided on the actual device, and that's not great for the retailer, because It's a capex. It's a huge investment that they have to make on those expensive devices. There's a security risk to have expensive devices in their store, and also they're inflexible. So when they want to sort of upgrade the application or change the experience that they're trying to create, it's difficult for them because they've already made that investment in those devices. And so broadly speaking, edge is somewhere between these devices where software is tightly coupled with hardware and the internet, or where the data centers are today. And there are different almost levels of edge computing where you have say the device edge, if we start there, which is, sometimes you can think of smart devices being a device edge, and this is a bit of a grey area of, when is it an edge device versus just an ordinary end device with some compute processing. I think the key thing is that device needs to be, virtualized, if you will. It needs to have some of the capabilities that you'd associate with almost like a cloud application. And the types of applications that should be deployed there, it should almost be drag and drop, where it's a cloud native application that you could run in a remote data center, you can now run on a device edge. And so examples of devices here could be like a smart camera, where the OEMs are making their these devices which used to just pretty much collect data and do some pre-processing, allow them to do more of the analytics and things like object recognition, that sort of thing. And I guess there's some quotes here. We've spoken to a few companies in the past who are either solution providers. So here we've got a video analytics solution provider, and what they why they see there is a move towards device edge. And then in other cases we've spoken to sort of end enterprises. The second category of edge is on-premises edge, which is putting the edge compute resource, at the customer site, at the enterprise site, which could be a building, could be it could be a factory, it could be a retail store, as I mentioned, it could be a hospital, and a lot of the time, this is about keeping things secure in the customer premises, reducing latency by putting those applications closer to the source of the data. And then the last kind of category is network edge or multi-access edge computing. And this is coming from the telecoms industry, where they are evolving their networking sites. So they have points of presence or facilities that are running their network functions and their network infrastructure. They're evolving those to become more like data centers. And so they by hosting applications on that type of edge, you dramatically reduce latency, because you reduce the need for the application to go through the network and back, and reduce that round trip time. And it's interesting, I guess, to see what the public cloud providers or the hyperscale cloud providers are doing in this space, because they are moving to the edge. Their bread and butter is the centralized cloud. And, their data centers would be that sort of internet bucket, as I had in the previous slide. But I guess initially they all have sort of some level of CDN offerings, and they have access to more regional data centers and space in internet exchange providers, for example, and they are increasing their footprint in those data centers. But that's always primarily been for their CDN service or for their internal applications, if you will. So, for example, even though Google's not on here, Google uses its own CDN network and sort of CDN data centers for YouTube, for example, to cache YouTube. I think what's changing is that they're now starting to evolve that those CDN data centers, or the premises which they use, the third part, or the colo data centers that they are using, and the stack that they've put in there. Before it was all about storage and caching. Now they are evolving it to make it about compute, and so they will start to allow developers to access those more regional data centers and regional locations. And so AWS, for example, announced local zones, which is a flavor of that, and then Azure has Azure Edge Zones, which is their sort of version of a kind of a regional data center play. So as a developer, you could now go on to AWS or Azure's portal, and instead of clicking, the Europe South zone, for example, you would be able to specifically select a region within that. So just hypothetically, it could be something like Milan or something. And then I guess the next sort of chronologically, what happened next is that they moved into the on-premise or the device world and tried to bring in some IoT services with things like Azure IoT Edge and Greengrass, and that was a software-based solution. What they've done since is evolve that to actually provide a compute device as well, so the physical element, and that's where Outpost and Azure Stack Edge come along. And then more recently, they're starting to move into the network edge and doing deals with the telecoms operators themselves so that they can put in their stack, which is essentially, a rack of their own servers into the telco's edge, and provide their cloud services from there as well. And so with AWS, it's Wavelength is their version of the network edge offering. With Azure, they have something called Azure Edge Zones with Carrier. So going back to then, the enterprise though, and why does the enterprise, where does Edge fit into their digital transformation? We've kind of talked about the benefits of Edge, but it all really fits into a more broad theme around digital transformation, because that's primarily what these enterprises are trying to do. They're trying to transform so that they can either improve efficiencies, whether it's about reducing waste and defects by automatically detecting faults in real time using sort of IoT devices, or it could be about increasing the asset lifetime by doing things like predictive maintenance to keep the asset running for longer. So these are the types of applications that Edge enables, which then enable digital transformation. And you can see some some quotes here about the dynamic between operational technology and IT technology, and that's coming together, and that's a bit of a challenge, but it's also quite key in edge computing. The other side of digital transformation are these new business models. So some of the underlying objectives are about improving efficiencies and primarily saving costs. But on the other side, you also have sort of the new business models element, where in many industries, they're moving towards more service type business models. So, X as a service, or taking manufacturing as an example, they're doing things like providing assets as a service, where rather than a traditional business model where they will ask the customer to just pay for the product up front, they'll provide it as a service, and they'll bundle in maintenance services and insight services, and allow the customer to know, if it was an engine, for example, they would allow the customer to know where the engine is, how it's running, how, if there's any problems with it, that sort of thing. And that's quite core for them to survive and to evolve and to keep growing their revenue base. The second thing is just sort of a more data-driven business model, where you have this sort of data-driven product development going on. And again, just taking manufacturing as an example here, they need insights on how their products are being used to be able to create the new version of their products. Whereas before, they sort of sold them and they had no idea how the customer was using them, who was using them, why they were using them, and all that sort of thing. And that's quite key for them to, again, for competitive reasons, to develop products that are beneficial. And now I'm just going to go through a few examples here. So first one is in manufacturing, and I think I've explained some of this, where you have kind of an edge compute platform in the manufacturing plant, and it's doing things like transforming data, aggregating data from multiple machines, filtering data that's not interesting, where, for example, you have all this raw data coming in from the sensors. What you really want to do is be able to filter out the anomalies, for example, and just send the spikes or the troughs to a cloud. Some machine learning algorithms might be executed on the edge compute as well. And that enables applications like condition-based monitoring, which is sort of what I mentioned earlier about being able to remotely monitor assets, predictive maintenance, which is all kind of a step above that, using now AI and ML on that data to be able to predict when a machine is going to break down and make sure it's fixed ahead of time. And then you have things like just general real-time automation of the plant. And this is, fundamental for manufacturing as they try and evolve their processes to become Industry 4.0 and IoT based. And I've just got a few logos here to show some companies who are providing some of these edge analytics capabilities, these sort of software platforms, if you will. Another big application for Edge is AR and VR and a sort of immersive experiences. And here I'm just showing, I guess, different compute resources where you have device, on-prem Edge, network Edge, and the cloud. And what happens today is that you have sort of AR applications that could be rendered. So the actual virtual reality could be rendered from the cloud. And the problem with that is latency, and it's very critical for AR and VR, especially for virtual reality, because your frame of reference is what you're seeing in front of you in that virtual reality headset. So if you move and the image doesn't move with you, that actually sort of creates a motion sickness element. And so the milliseconds that are required are sub 100 milliseconds between round trip to enable that AR VR application to work properly. And I think what we've seen today is that actually most VR applications are run from the device themselves. So you have the content loaded on the device, or you have it, the device tethered to a local compute or a laptop to do the actual rendering. And that's not ideal, and that's not going to allow AR VR to scale. You need it to be fully mobile, and you need it to be sort of wireless. And so that's where the network edge or an on-prem edge can really benefit, where you run the AR VR application or you render it from a network edge, so that you can reduce that latency to under 100 milliseconds, and you then only use the VR headset to display what was rendered from the network edge. And these these types of things are quite core in say a retail setting, because retailers are trying to, as I said, create sort of immersive experiences, both at their stores, especially in flagship stores. You have lots of sort of immersive boards or digital signs. You have AR VR happening, and also in the home, where today e-commerce is evolving quite quickly. You can use your mobile phone to sort of look at the product and maybe sort of look at it on you virtually, or look at how a piece of furniture looks in your room, and that all uses augmented reality. In the future, we will start to see more of that, and to have very sort of high quality, high definition AR VR. And as the quality of the image increases or improves, that is a huge strain on bandwidth, and that again it drives a need to move that data, not run it from the cloud, but at an edge. And here we've just got a few examples of companies again who are starting to do things around this space. Some of it is AR VR, some of it in the retail setting is more about immersive experiences more broadly, and using things like IoT and digitization technology to be able to create what Momomi is doing, which is a sort of augmented reality mirror. So you can go to a changing room and try different things on virtually, without having to actually get the clothes, which is quite an interesting concept. And again, just sort of bringing it to life. So how is edge compute being deployed? Well, there's both brownfield and greenfield deployments. You have these are sort of edge compute use cases like condition monitoring, which I mentioned about remote monitoring an asset. Some of that edge computing is happening on a virtualized programmable logic controller, so actually changing what that PLC does. Sometimes it's on a sort of a separate device, a server or a gateway, or it could be deployed on a rack of servers in the premises, or it could be on a kind of on-premise data center. So all these things are very customer dependent. There are different ways of deploying edge depending on what the needs are and whether there are other edge applications which need to be deployed too. And in terms of where we are, so we have edge compute, which has kind of happened for some time. This is sort of the broad idea of on-premise data centers is not necessarily new, but historically it's been a bit more standalone, where you have the cloud and then you have on-premise, and there's less of a distributed compute spectrum. This idea of edge cloud is really about moving towards distributed compute or distributed cloud, more multi-cloud, also having sort of hundreds of different compute infrastructure out there, where as we saw on the previous page, these could be small devices or a single PLC or a single gateway to a whole rack of servers or a full data center. And the software is quite important in edge cloud, where it needs to be a sort of containerized environment, in particular to be able to move workloads quite seamlessly across different clouds and to be able to access those as a service business model. So even the hardware vendors are moving to sort of as a service business models, and they can only do that if their platforms are flexible and if they can monitor their platforms and monitor their hardware remotely. So mapping sort of the use cases on the spectrum. Some things are at quite an early stage when it comes to sort of autonomous driving and, managing traffic sort of automatically, and some of these more custom engagement, very AR, VR heavy applications. But there are use cases and applications which are more advanced. So for example, asset tracking, that has been using some level of edge compute in the vehicle, for example, for a long time. Or cloud gaming, we're starting to see cloud gaming being deployed in regional data centers, which are a form of edge, you could argue. Things are moving quite quickly, applications are moving, sometimes other technologies need to come together and sort of advance, whether it's in the IoT space or AR, VR, to sort of push things along. And then I guess the last thing I wanted to touch on is just the edge compute challenges, and this range from, some of the barriers to overcome. This ranges from sort of organizational ones and non-technology challenges where you have conflicts between IT and OT, for example, and that's something that's prevalent as, say, manufacturers move to Industry 4.0. And in general, in other sectors, say oil and gas as well, IT and OT have been quite distinct. Now with edge, they're coming closer together. And there's a challenge of who's the decision maker there. Is it someone who heads up IT? Is it someone who heads up OT? Is there a need to evolve that organizational structure? Second thing is about culture and education. As with any change, this takes time. It takes time for enterprises to implement these new applications. So for example, predictive maintenance, that fundamentally changes how maintenance is conducted. And that takes time to train people about it. It takes time to make them comfortable about it, and then to allow them, to give them the tools to use that technology. Third thing is data compliance regulation. I think I mentioned this at the start, but that's becoming increasingly a challenge. And the challenge is not just being aware of different regulations. So say for a multinational, they need to be aware of different regulations, different jurisdictions, but they also need to be able to manage their data seamlessly. And today it's quite manual in the sense that they sort of either store data in a data center in India, for example, or in China. They have to manually move that data, or in the US, or in Europe. Ideally what should happen is that things are automated in a way so you can almost label data, and that data moves in the right edge or in the right cloud, depending on the needs of the enterprise, and also depending on who the user is and where that, which jurisdiction is relevant to that user. And then the last ones are a bit more sort of technology focused, where the first thing is that, because of this move from, a lot of IT is coming into OT, and that's a big part of edge, moving using that IT-like infrastructure for OT in an on-premise environment or in some kind of edge-like environment. But the challenge is that it's not drag and drop, and that there do need to be some changes. So this could be about things like making equipment more ruggedized, the servers more ruggedized, so that they can withstand the environment in harsh conditions. For example, in a remote oil rig. Or it can also be about making it suitable for the customer's needs in almost the opposite way, where, again, like taking retail, or I don't know, for example, in a kind of a more hospitality environment, or in a stadium, or whatever it might be. You don't really want huge deployments of edge compute, physical deployments. You need things that are small, that can slot in easily, and don't take up too much space. And then second last thing is about making the business case. Enterprises do need to have a think about what's going to be cloud, what's going to be edge. There is a cost associated with both. It can be difficult, and a lot of these industries are already cash strapped. They're already in a hugely competitive environment, so it's very critical that there is a clear business case for changing how their infrastructure evolves. And then the last thing is the partner ecosystem. And again, edge is still relatively new, and it's not so clear who are the leaders in edge, or who to partner with. And it's quite fragmented, because you almost need different parts of the ecosystem to bring it all together. And this diagram here sort of shows that, where this is kind of essentially the value chain of edge, where you have the facility, the premises, the network part, or connectivity, hardware, software infrastructure, etc. all these need to come together, and there are specialists in each domain, so it can be quite confusing for an enterprise, but it is quite important to pick the right partners to build your edge compute. So what to do? Well, first thing I guess, is to build that business case, define the key drivers, the KPIs, figure out which applications need edge, understand this difference between IT and OT, and how to bring those together, whether there's also an organizational structure that needs to take place, that's almost its own business case in its own right. Second thing is defining some guiding principles to make sure that the plan is future proof. So what I mean by that is that what edge computing is allowing enterprises to do is to learn from the mistakes of the past, where traditionally it's all been about proprietary systems, and that has got enterprises in certain industries in quite a difficult position, as they have had external pressure to evolve and they are being disrupted, but they're unable to change because their physical or their IT and OT infrastructure is not flexible. So it's important to make sure that even though maybe the applications for edge are not clear yet, and it's there is an unknown for the future, but to actually put that foundation in place that will be future proof and will allow the enterprise to be flexible and to change things going forward. And then the last thing is about selecting the right partners. So there's lots of different technologies coming together here, not just in edge, but there's sort of 5G coming in the horizon. IoT is a big part, AI and ML and AR, VR and all these things. And so again, you need to make sure you have the right partners who understand these technologies and are able to augment them into their solutions, if not today, then in the future. And the other thing is that, it's great to have partners who can bring others together. So a lot of companies now, or some companies now, are really taking a role in bringing the ecosystem together and building that ecosystem. And that's across software and hardware and services and that sort of thing. And that's kind of critical for this too. So that's it for today. Thanks everyone for listening. I hope you found it useful. I'm happy to take any questions offline. Thank you very much.